And we're live. Hey guys, welcome to the live stream. Today we are going to be attempting to create somewhat of a game for Ludum 42. Now this is my first one, and obviously I don't have a ton of time, so I'm just going to try to create a simple classic snake game because I thought that fit the theme well of running out of space, and we're just going to use Java for that. We might implement some graphics. We'll see how long this takes. So we're going to go ahead and we're going to just call this compo, and we're going to launch it. And we're going to go ahead and open our workbench, start coding right away. That should be good. So we'll create a new Java project. We're just going to call this compo. And then we're going to go ahead and create a new Java class. And we're just going to call this snake because this will be our main class. So we'll go ahead and right off the bat, we're going to start implementing some stuff. Well, caps lock. So we'll go ahead and write our main method. So there's our main method. And then we'll go ahead and create a constructor. And then we'll go ahead and create our frame. And then we're going to say frame equals, or actually we'll just equal new JFrame right away. And then we'll import it. And then we're going to say frame dot set size. And we're just going to go like, say, we'll go 600 by 600. It's probably a good number. We're going to say frame dot set default close operation, and 3 is the exit on close. And then we're going to say frame dot set location relative to, and then no will center it. And then frame dot set title, we'll set that equal to snake. Frame dot set, we'll just set it visible, see if we're missing anything. So if we run this, it should create that. So now what we need to do is we need to set up a rendering system. So we're just going to use Swing for that, and we're just going to use a buffered image. So we'll just create a static buffered image equals new buffered image, and we'll go 600, 600, and then 1 is the default int RGB. I don't ever use that though. Static, and then we need to create a graphics 2D object equals image.create graphics. And then what we need to do is, for some reason, graphics 2D. Oh, we need to give it a name. We're just going to call it G. And we'll import it, obviously. Graphica, no, graphics. There we go. So if we actually, what we're going to do is we're going to extend JPanel for our class. And then what we're going to do is we're going to create a public static void paint component. And it'll take in a graphics G object, import it. And what we're going to say is g.drawImage And obviously we're going to draw image at 0, 0, 600, 600, and then we'll just set it equal to null for the rest of the values. So that should draw our image. And then we need to create a game loop. So we need to actually create a static, just go up here, static timer t, or timer equals, actually we'll have to, and then what we can do is import our swing timer, and timer equals new timer, and we're going to go 20 this. And then we need to, we need to implement action listener. And then we will implement our add our unimplemented methods. So, and then what we'll do is we'll just .repaint. And then we'll also use this as our game loop. So we should have, we obviously have to start timer.start, and right now our constructor is never being called because we don't have a static snake main, and then main equals new snake, something like that. And then we're also going to say frame.add this. And if we have everything loaded, it should be black. And if we wanted to, since we have it looped, we can just say g.draw or fill rect 0, 0, 100, 100. See if it might be black right now, but no, it's white. So that means everything is working and we have a running game. So now that we have a rendering system, we're going to go ahead and create our snake object. So we're just going to create a new class, and we're going to call this snake obj. And we're going to create a constructor. We're going to create a few more methods. We're going to create a show method. We're going to create a move method. We're going to create manage food method, manage death, and just so we can, actually I think that's probably good for now. I probably forgot something, but that looks good, because that's really all you need for a snake game. And then we will move. Obviously we need to have a time restraint, so, and I don't like 20, so what I'll do is I'll just pass an integer t, and we'll create a timer t equals timer t, import that t equals new timer t this, or this.t, and then t this.t dot start. Then what we need to do is we need to implement action listener, then import it and add unimplemented methods. Then we'll go ahead and say move equals true. So we can say if move equals false, and then we need to create a value for move. So that should also, and then what we need to do is we need to create an array. Oh, that's not even, actually, you know what, we will go with array list because I like array lists a little bit more, and we'll use dimensions to store our values. We'll call this the positions, and then there's that. We'll import both of those. Boom. And then we'll say positions equals new array list of dimensions. Boom. And we'll say for int I equals 0, I is less than, we'll say, or actually, no, we'll go 0. I is less than 3. I plus plus. Then what we can do is we can say positions.add new dimension and we'll just say, actually, if we bump this up, what we can do is we can just say our x value will be equal to y. And how many tiles do we want in a row for our snake? I'm thinking probably something like, well, let's see, what's 600 divisible by? So we can obviously do 600 divided by, oh, clear. 600 divided by 10 is 60. So, but what about like 15? Because I think 15 will probably work best. Oh, that works out perfectly. So 15 divided by 2, and since we're going to be drawing from the top left corner, we're going to want to round down. I at 7, and then we need another parentheses. So that should create a new snake object that will move, and then what we can do for our show is public, or we can create a for loop. I is equal to 0, I is less than positions dot size, I plus plus, and then we're going to say snake dot g dot set color, new color, some sort of blue. Here, let's go to like whatever, RGB picker. RGB Explorer. Looks like a good website. So we obviously want to go something probably like 170-ish. You know, I like that. So we'll go like 30, 30, 170. So that should be pretty good color. So 30, 30, 30, 170. And then we'll import color. Snake.g.set color, or fill rect is going to be at positions dot get I dot x, and then we need to multiply it times 40, and then we can do the same positions dot get I dot y times 40, and then the width needs to be 40. Oh, x, why am I using x? I'm used to using vectors, but Java doesn't have a super simple vector, so I just use dimensions. So let's see, we should have a system to draw, and what we'll do is we'll actually create our system to move. So we need to create a value called direction. So, or actually, you know what we can do is we can use integers for this, because I don't like strings. So int right equals 1, left. We'll go like left equals 2, up equals 3 down equals 4. So there we go now, and then we can create an int dir, and then dir equals right. So what we can do is we can say if dir equals right, and then else. So that's good, and then we can go up and down. So then what we need to do is we can say positions dot remove, because we can just remove the first one and then add a new one in the desired direction. Positions dot add, and then we'll just go like this. New dimension positions. And what we're going to actually do is we're just going to create a dimension head equals positions dot get positions dot size -1, because that'll hopefully make things a little bit more convenient. And then we can just say head dot x plus 1, or head dot width, and then head dot height. And then we'll copy this for the rest of them. And we can subtract 1 here. And then for going up, we can still subtract 1. And then for going down, we can add 1. So that should let us have a fully working and moving snake. And then what we can do is we can create a static snake object, snake, and then snake equals new snake. And you know, honestly, I probably don't even need this variable for t. We'll just manually set it because it doesn't have to be clean. We'll just set it at like 100. So if we run this, hopefully, and if we there we go. And then what we can say is we can say snake.show, snake.move. Oh, that's good. And then what we need to do is we need to just say g.setColor, new color. We'll just go like a gray color. And then g.direct 00 600 600. That should be all good. Now we should have a moving snake. Now obviously we need to add key input, so let's do that now. So then we'll just minimize this, and we'll say if key dot, and we'll just create key code key equals key dot get key code. Is it key event? let's see, e dot get e. Oh, it returns an int, so we'll just create an int key code. For int key equals e dot get key code. And if key equals key event dot vk write, and we'll just copy this a few times. There we go. We'll copy this for all of them. Okay, then what we need to do is we need to create a function to simply, and the reason we're going to create a function to set the direction is because we want to be able to prevent it from just setting it randomly, and we don't want to have all that confusing code in our key event. So we're going to create int d, and then for now what we'll just do is dir equals d, but it'll be more convenient later to have that function. So then we'll say snake.set direction snake.rate. And then we'll just copy this a few times. We'll go right, left, up, down. Now we should, if everything went well, have a moving snake. So that's great. Now we have the system. Now we need to implement our food. So we'll go ahead and go food. We'll create just public food constructor, public void generate result costs, public void check costs, and then we'll just check costs in here, and then the first thing we'll do is we'll call generate costs here. So then what we can do is if we, and then we'll also create a void show. And then we'll also put the computing or a function that will just tell us if it's eaten. And that way we can just use that in our manage food function. So let's see. So what we can do is we can just create dimension d, and then d equals new dimension, and then we need to cast int math.round math.random times, let's see, if we have 15 tiles, well, since it's gonna, we have to subtract 1 from it, and then we'll just copy this because we just need 2 random values. Import, oh, we gotta import dimension. So then what we'll do is we'll also create an array list dimensions called p, and then what we'll do, or we'll say if, or we'll create a for loop first. And then we'll say if p dot get I that equals toss, or I'm actually going to just call it pos because I don't like D, so we'll just call it pos because that'll be the position of our food. So then if that's equal, then we'll just call check pos again. Sounds good. So that's great. Then what we need to do is we'll say snake.g.draw or .set color, new color, some sort of red. We'll just look at the, so why did processing open? We'll go apple. Oh, it's obviously it's gonna look up the company Apple because, so we'll just go something. Actually, that's not even gonna help us. We'll go back to that RGB Explorer. I think that's a good apple color. So what if we went like 250/50? Sounds good. 250/50. Then we'll import it. We'll say snake.g.billRect pos.width pos.height 40. Oh, we actually also have to multiply it times 40 because we're just using the grid system. And then what we'll do is we'll say if p or dimension head equals p dot get p dot size minus 1. And then we'll say if head dot equals pos return true, else return false. So now what we can do is we can create a function or a variable food, and then we'll say food equals new food. Don't think we need any values. Looks good. And let's actually just to make sure, let's take in a array list dimension d p equals d. And then what we can do is in our manage food function, we'll say food dot p equals positions, and we'll say if food dot is eaten, food dot check pos, and then we need to show the food. And we also need to add, we'll just call a stop delete function equals true. And then we'll create for our move function. Then what we can do is we can say if not stop delete else stop delete equals false. So this should make it so if we eat the food, then it'll set stop delete equal to true, which will stop the delete for one movement, thus making our snake longer. And then if we call snake.manage food, we should have a food object. That did not work very well. So he's definitely getting longer. So there is a basic snake game. We gotta actually, we'll do some graphics in a second, and we'll also add death. But that's pretty challenging. So we'll give it a shot with graphics, or with death. So snake.manage death. So if, let's just create another variable head, because we're going to base it all of our stuff equals head, dimension, head equals positions dot get, positions dot size minus 1. That was not correct syntax at all. I don't know what I was doing. But good. And we need a parenthesis. Okay, and then what we can say is if head dot width less than 0, or head dot width is greater than 14, or head dot height is less than 0, or head dot height is greater than 14. We need to actually create a function to reset the game. So what we can do is we can just go to our constructor and just copy this basic code into a function that will work well. Let's call it reset game. Okay, then we can just say reset game, and actually we need to also call it from our constructor. We'll save that. And then what we need to do is we need to create a for loop for this one. Int I equals 0, I is less than positions dot size equals plus. Beautiful. If head dot equals positions dot get I, reset game. So now we should have a fully functional snake game. I don't know why that did that. Try it again. Because it obviously didn't do that. See if it's in here. Is that the problem? Oh, shoot. You know, I've had this problem before. In games where, actually, no, you know what? I haven't had this problem. What am I saying? You just have to subtract head. I just thought about this problem, I mean. So now we should have a fully functioning snake game. I'm growing, I think, too fast. I have no idea though. Oh. No, actually, I don't think I'm growing too fast. Right, so you can't measure yourself. You saw it did kill me. And what we'll do is, what we need to do is, what was I thinking? Hold on. yeah, you saw it goes to the bottom a little bit. So we actually need to add a little bit of slack, and it's like what, like 20 something pixels. We'll go 22. I don't care. I think that it works nicer. Oh, well, it clearly didn't work this time. That's because we didn't change the actual size of the J-frame. So that's all you really have to do. There we go. Oh, yeah, so what there's a glitch. So what we need to do is we need to set previous dir. So we need to create a variable called previous dir. And that we make sure we don't run into ourselves. So we'll just previous dir equals right for the start. And then whenever we move, what we want to do is we just want to set previous dir equals dir. And then what we can do is we can say if dir equals right and previous dir does not equal left. And then you create a few of these. And by a few, I mean like 4. Okay. And that means this. Okay. So that is all good. And then we'll set this equal to left. We'll set this equal to up. Set this equal to down. Set this equal to right. Set this equal to down. And we'll set this equal to up. So now, if I click right, it's just going to kill me. But that's not good. So you just killed me. That's not a good thing. So everything looks good. Else, I don't know what the. Oh wait, it's because it's still just gonna kill us when we move. We have to actually check the value of D instead of dir. Oh, there we go. Now it's not killing us. There. So this is a fully functioning snake game. Now what we need to do is add some more beauty to it. We'll start off by creating something to render images. We'll just create a little function, nice and simple. And we're just going to call it public void load image. I'm just going to pick a string called path. We're just going to say try. Say buffered image equals image io.read snake.class.get class loader.get resource as stream. And we'll just return this. Else or catch image IO or IO exception. E. Import e.print stack trace and return no. What's the problem? Oh, it's because it's a void. Oh, that didn't even make sense. Public buffered image. There. A function that shall load an image. Now we shall create a new class. So we create a new general folder. Resources. That was a package. And then what we'll do is we will add it as a class folder. Not build path. Resources. Yes. Yes, beautiful. Most beautiful. And then we will open up Affinity Designer. We will create an apple, not 1,000 by 1,000. No, just 100 by 100. We will use just vectors. Yes, just the pen tool today. Yeah, it's a little bit harsh. Okay, that looks beautiful. Yeah, I don't like this at all. Let's see what I can use. What about using the tier for the bottom? That looks a little bit better. And what is the color that we use? I think it was like 250. 50. Looks good. I'm gonna just take this one a little bit. Just gonna slide it in, just a smidge. Make it look a little bit good, a little bit better. Okay. And we're gonna take another one. We're gonna draw it right here. We're gonna flip it over. Yep. That's looking good. And then I'm gonna take it again, and I'm gonna flip it. And then I'm gonna combine all of these. Then I'm gonna delete this. Can't tell. Oh, shoot. There we go. Then I'll delete this and this. Pull this out. And then I'll delete this, delete this, delete this. Pull this out. Beautiful. That is definitely an apple. Then we'll just go ahead and get a paintbrush. Set it equal to black. Definitely not 34 pixels, but something like this. Okay, that's a little bit too much. There you go, 100% on the hardness. And I don't actually, I think this is a little bit too thin. Okay. At 100 pixels, I don't think that's gonna look half bad. So we'll go ahead and export this. To the compo resources apple.png. Okay. And we're gonna just create a buffered image. Apple equals snake.load. But we gotta make it a static method or it's not gonna find it. Snake.load image apple.png. Wayne. Okay, that's good. And we just need to change this to draw image and say apple. And then just say no. So hopefully that's definitely a null pointer exception. I probably missed it. Oh, maybe I didn't import it. That'll do it. I still got a null pointer exception. Oh, I know what I gotta do. I gotta like refresh it. Refresh. There we go. I'm just gonna have to reset it because I don't like it. And then there we go. So if we load it now, we should have our beautiful apple. Are we still gonna get a null pointer? Did I say just check this? It's definitely in there. Apple.png. Apple.png. Looks like it matches. I don't know. It's not loading. Maybe we need to refresh the whole thing and restart it. Huh. I'm gonna retract rate in this. Okay, let's just try to create a new folder. And we're gonna call it res. And we'll go like that. And then we'll go ahead and go properties. Okay. Remove add class folder res. Okay, applying close. And then Affinity Designer. I'm gonna have to export it again. Apple.png. And we'll go to our desktop. Okay, it should still work. I don't know why it wouldn't work. Let's try it. We get a null pointer exception. Snake.show. I might have changed something I shouldn't have. have a feeling that something happened to our snake object. There we go. I don't know what the problem was, but looks good. So it looks like we got our image system working. I don't know what the problem was, but I don't really care. I ran into myself. Okay. Well, that's good. I think we're gonna do a few more things before we wrap it up. So we just gotta make our snake look nicer. So first let's create like a background. Actually, we'll do this in code because it'll be easier. So we'll just create a function. And then we'll just go ahead and say draw background, and then we'll say for int I equals 0, I is less than 15, I plus plus. And then we'll just create a nested loop because I don't really feel like coding because I'm tired. Okay, so then we say if I equals, or I modulus 2 equals 0. So if I is even, that means because we'll use the I for the x, so if I is even and j is odd, or j is even and I is odd. Okay. So then if I is then and j modulus 2 equals 1, or I modulus 2 equals 1, and j modulus 2 equals 0. And then we need one more. And we can just say g dot set color new color 30 or no 30 like 170 30 I don't even care. G dot fill rect at I times 40 j times 40 40 40. Good. Okay. And then we gotta call this in our game loop. Oh, that looks cool. But obviously we want a little bit of lighter background. 50, 150, 50. Be a little bit like more. Ew, that color is awful. We're gonna go 10, 150. Yeah, I think that's good. I mean, it's not perfect, but it looks pretty good. It's a pretty good snake game so far. So there's a few more things I want to do. I want to draw the snake using images instead of whatever it's called. Oh, instead of rectangles. But for now, this is a pretty good game. So let's get started because otherwise we're never going to be able to finish this. So let's just create a new 100 by 100. And we're going to have to really go with the rounded rectangle. We'll go with that 30, 30, 170. Looks good. And then what we need to do is to create some eyeballs. So we'll go ahead and for this, we'll set the height equal to 80 pixels. Okay, so I think I'm actually just going to go ahead and copy this, paste it. I think that looks good enough. I'm getting tired. Then we'll just go ahead and create a new one. We'll copy and paste everything in here. And then we'll just delete the eyeballs. I'm just going to do 2 separate bodies. Pieces. Paste it. Delete everything except for the body. And then we'll export this as body sideways. And then we will rotate it 90 degrees. Center it. Okay. Body vertical. Okay. Okay, now what we need to do is do some work in the show class. So we're going to start off by going 0. We're going to start off by not drawing the head and tail. So I think whenever we're defining positions somewhere and we're doing it wrong, oh, stop delete equals, we gotta make sure stop delete equals false, obviously. There we go. So there's the snake drawn without its head or tail. Now what we can do is we can say if there equals right shoot. I am gonna die before I finish this. And then I'll go left. I'm getting a little quiet. And we'll just say, we'll create buffered. We'll create an image for head. Okay, we'll just create and define transform at equals we'll import it equals define transform dot get translate instance positions dot get positions dot size -1 dot width dot at the x value dot at the y value. Okay, and then at dot rotate 180. Oh, actually, we don't need to rotate it at all. We'll just scale it 0.4 because it's 40 out of 100. Okay, and then we'll just say snake.g.draw image. Head at null. I like that a little bit more. Oh, yep, it's obviously messed up a little bit. So the eyes look a little bit small. Should be an easier fix though, because we made it relatively easy to change. Looks better. I like that more. So we'll just export this as replace, refresh. I think it looks better. I like it. Okay. Now all I gotta do is do the rest of the body, and I think we're gonna call it because it's already 9:30. So let's rotate them. And we're gonna rotate them around the center. Probably we don't have to do any shifting. I take that back. We're probably gonna have to do some shifting for some reason. Oh, maybe it's because we have to do the scaling after we rotate it. That might work better because I feel like that'll help it. I don't know though. There we go. So that looks good for the head. Now what we need to do for the tail, or actually what we need to do is we need to make sure we move first. So what we'll do is we'll just create a variable called change head. And then when we move, if we move, it'll say, or if we set our direction, if change, or we'll just say change head equals 1. And then when we move, change head, or if change head, well, we'll make sure we move first, but then we'll do it. If change head equals head, or 1. You know, actually, what if we just draw it from the previous stir? Let's try it. There we go. Okay, now what we gotta do is we gotta do that for the tail. You know, I'm gonna actually slow down the movement just a little. Because what is it at? It's probably at 100. We'll go 150 because I mean it can't hurt. So ridiculously fast, but it works. And then what we won't actually need change head if we go like this, and we can go ahead and remove this change head and remove this. So now what we need to do is we need to copy this for the tail. Except we need to create an array of dir. Or an array list of dir. I don't know. So I guess what we're gonna have to do is we're gonna have to use strings, and I don't like using strings. So let's see if and then what we'll say is dirs equal new array list of string and then we're gonna say, yeah, that should work. Right. So then what we can say is we can say dirs dot remove 0, and then we'll say dirs dot add because this will be based with strings. So that means that this way, if we say if we say prev dir, and we say dirs dot get 0, that might work a little bit better. Man, I am so tired. I can't wait till we finish this. And we have to change and what we gotta do is we have to go let's see. Oh yeah, it's drawing up the positions. We gotta get position dot 0, get 0, 0, 0, 0, 0, 0, 0. And for some reason, it doesn't want to rotate. Now it's rotating, but is it? Oh, yeah, we gotta rotate it before we scale it, I think. I'm just gonna create an affine, or find affine transform AT. Just gonna replace it with AT for all. And we'll just create an affine transform AT. I don't know if that'll do it, but it might. Dirs.remove. Oh, shoot. It's because it's always equaling right. You have to set it equal to left, up, and down. That's super silly. A super stupid mistake. Okay. So that's good. Now what we can do is we can 90 and then negative 90. I think that's right. And then I don't know why, but we might have to just use dirs.get1 to stay synced up properly. Sure. Yeah, now it's always in line with the snake apparently. So we got the head, we gotta get the body and the curves worked out. And then we're gonna be done. Or actually we gotta create a main menu still. Man, I'm really tired. Okay. Let's create our body. That shouldn't be super hard. So what we'll do is we'll just say snake.if dirs.get I equals right, or equals right, or equals left. We actually need to body sideways equals snake.load image. Okay, let's see. Body sideways .png. Okay, let's get this done. What's our bug? No, it says we have an error. Let's see. Do we? I don't actually think so, but we might. Body sideways .png. Oh, we spelled vertical wrong. Okay, well then that'll do it for you. Let's try it now. So now all we gotta do is we gotta figure out how to draw curves. Curves don't work in our system yet, but now curves, main menu, and we're done. Although I do kind of like this effect. Oh, I just ran into myself. I'm gonna slow this down a little bit though, because it's still a little bit too jumpy for me. At least 200. Oh, okay, it's a little better. Okay, I like it. Now let's create a curve. So let's see. So if our thing is average width, we need to have it, or if it has 80, we'll need to go 180 by 180, I think. First we'll take off 10 from each side. And then what we need to do, convert it to a donut. What is 10 pixels of 90 pix? 9/1/9. Let's see. 90 divided by 10, 9. So let's see, 1/9 is about 11%. So we'll go like, I don't know what I did, but we're gonna go 10%. And then 30, 30, 170. And then we'll export it as curve.png. Refresh. Okay, let's see. So if we'll create a for loop. If curves.get I does not equal curves.get I plus 1. Then we're going to find out if dir.get I equals right and dirs get I plus 1. Oh, well, actually, we'll go left because I don't want to do any rotating yet. No, actually, we have the pattern of right and dirs get I plus 1 equals left or equals down, right? Sure. And if or dirs get I equals left or equals I don't know. We'll try it. And dirs get I plus 1 equals up because I think they have to be backwards. At math dot 2 radians. It's going to be like -90, and then we need to do 20, 20, and we need to create a buffered image curve equals snake.load image curve.png. I'm just going to turn off drawing these guys so I can actually see. I think we have to just leave it like that. I don't know. Maybe we have to go 180. Try that. Try that. And if we get longer, it should stay there still. What about up and left? I think we have it backwards, so that should work. There we go. So now we got that curve working. Let's do this for the rest of them. Not what I meant to happen. Okay, I'm really tired. So let's see. We probably want to rotate it like 90 degrees, at least so we can see. Come there. That was right. Let's see, 180 degrees would be like left and down. And then up and right. I think it's just negative 90 then, maybe. I don't know. Yep. And we gotta do this one. Should probably be like left. Or it'll be like left up, probably. Left up or down right. And that should be 180. So now all I gotta do is add the body back. So what I'm gonna do is create an array list of booleans called drawn. Drawn equals new array list boolean or just add false. So every time we run the show function, we should set drawn equals so that should skip the head then. And then get Okay. Then we should set drawn dot set I true. If drawn dot get I or int I equals 0, I is less than positions dot size I plus plus drawn dot add false. Now we have our snake and it should wrap however we want it to. So that's pretty much it. Now all we have to do is add a main menu. Pretty happy with how this has turned out so far. Okay, well then, let's add a menu. And so let's see, what we need to do for our menu as our last step is we need to say if we reset the game, which we'll be doing automatically at the beginning, we just need to say is dead equals true. And if snake dot is dead, oh, I forgot to add a boolean called snake is dead. And we want to just manage death always. Okay. Else I'm going to do a main menu. Okay, and then we'll go ahead and create a new one, and it'll be like 600 wide, 200 pixel, like the top portion of our screen. And we'll just go ahead and put a nice big text box. We'll use like Chalkboard because it's a fine font to use, I'm pretty sure, for free. Because I know it's used in apps and stuff, so it should be good for us to use it. Then we need to center it. Okay, and then what we need to do is create a little logo that says press S to start. And we need to make it a little bit less smaller, so that something along the lines of that. And then we will export that as start.png. Okay, and we're gonna go ahead and buffered image start equals load image start.png. So there we go. Now what we gotta do is create a little function called main menu. There we go. And then we'll go main menu public void main menu. And then we'll say g.draw image logo at 0, 0, 600, 200, null. We need to also say g.set color new color 30, 30, 30. I like a great color. And then we can say g.fill rect 0, 0, 600, 600, g.draw image again start 0. We need to go like 400 minus, or no, we'll go, the center is 300, so we'll go 200. We'll draw it with like a 200 width. Let's see, what is the canvas? It's 600 by 200. So we gotta go 200, 400, then we can go 266, null. And then if we say event.s, well, we'll just say e.get keychar equals s. That, I think then snake dot is dead equals false. And then we will test it. I don't know why it's running right away. Oh, snake dot is not dead. So that is pretty much it. I'm pretty happy with how this came out for 2 hours. Pretty tired. And obviously, I'm not equipped and set up to participate in the full Ludum Dare challenge, but I had fun making this little game, and let's upload it. Okay, so let's just first, let's just export. We'll just export as this jar. And what we'll do is we'll just go ahead and go PNG to ICNS. I think it's this one that works. And then we'll just click to browse. And we'll go into Compo. Oh, that's not even the one. And we'll just go. Oh, is it this? I don't even know where it is anymore. Here it is. Apple.png. Okay, we'll go ahead and download my CNS file. Wait, I don't even think jars don't have ICNS. What am I saying? Okay, we'll just go desktop. Desktop. Let's give it a quick test. Looking pretty good. It's a pretty fun game. I think I could do more with it if I wasn't so tired, but I gotta go to bed. Let's upload it. Okay, Google Chrome, upload game, source file. I don't even know how to do this. Graphics, audio. How do I think, oh, you know what? I'm gonna have to upload it to Mediafire. Okay, uploading. We're good. Here it is. Share. Copy link. And then we'll go here, here, here. Okay. Well, I don't know what to do for this part. What's the recommended size? 612 by 512. Or no, I think it was like 524. We'll give it a shot at 524. I don't know what it said. Oh, 640 by 512. I was way off. Okay. Let's do the same thing and go chalkboard SE. And then we get this color 15, 185, 255. 15, 185, 255. You know, honestly, let's copy this. Paste it. And I could just say and put this in the 30, 30, 30. And let's just build a snake. Okay. I'll just upload this desktop image. Upload desktop image.png. Okay, and we are submitted. Publish. I think that it worked. And thank you for watching this live stream. And I'll see you next time.